All right, let's talk about Python loops. We're going to dive into how to fix them, starting with some really common bugs, and we'll end up unlocking what I think is a whole new programming superpower. So let's jump right in.
So, I have to ask, are your Python loops secretly sabotaging your code? And I'm serious, because it's the loops that look perfectly fine that can hide some of the nastiest surprises. Okay, first up, let's tackle what I like to call the loop that lies. This one it's just so incredibly common. And the absolute worst part? It doesn't always crash your code. Nope, sometimes it just silently gives you the wrong answer, and you might not even notice.
Okay, just look at how sneaky this bug is. On the left, you see accidental success. You run this code to remove even numbers, and hey, it looks like it worked perfectly. But that's just pure luck. The real problem shows up on the right. See what happens? When the loop hits that first 2 and removes it, the whole list shuffles over. The second 2 moves into the spot the first one was in, but the loop has already moved on. It completely skips it. This is why the golden rule is so important. Never ever modify a list while you're iterating over it.
And hey, you don't have to just take my word for it. The official Python docs literally warn us about this. They say, and I quote, "It can be tricky to get right." Now, we all know that's classic programmer speak for just don't do it, seriously, unless you really know what you're doing.
So what's the right way to do this? Well, on the left, that's the chaos we want to avoid. But on the right, we've got 2 beautiful Pythonic fixes. The first one, and my personal favorite, is a list comprehension. You're not changing the list, you're just building a brand new one with only the stuff you want to keep. It's clean, it's safe. Now the second option is for when you absolutely have to modify the original list. The trick is to loop over a copy. See that little number slice? That creates a temporary copy just for the loop to look at, so you can safely mess with the original list without pulling the rug out from under yourself.
Okay, so we've squashed a pretty major bug. Awesome. But, writing good Python is about so much more than just avoiding errors. It's about writing code that's clear, that's readable, that's efficient. It's about being, Pythonic.
Oh, this is a classic. I bet a lot of you have seen or even written the code on the left. It's that old range len habit, maybe coming from other languages. And look, it works, but it's just clunky. The Pythonic way over on the right is to use enumerate. It's so much more elegant. It just hands you the index and the item all in one go. It's cleaner, way easier to read, and helps you sidestep those pesky off-by-1 errors. It's such a simple but powerful upgrade to your code.
All right, next up, the while true loop. It's so tempting, isn't it? I get it, but think about what you're telling the computer. Run forever until I hopefully remember to tell you to stop. That's a bit risky, right? Because if you have one little bug in your break logic, boom, infinite loop. The safer approach you see on the right is to put a clear, explicit exit condition right in the while statement. Anyone reading your code immediately knows when and why this loop is supposed to end, just from that first line.
And finally, for our Pythonic tips, let's talk dictionaries. It's super common to see people loop over the keys with .keys, and then, inside the loop, do a second lookup to go get the value. You're making the computer do double the work. A much better way is to use .items. It just hands you the key and the value together in one fell swoop. Your code is instantly more readable, and it's actually faster because you're not doing that extra lookup every single time.
Okay, so we've spent all this time learning how to loop better. But now I want to ask a bigger, more fundamental question. When should we even be using a loop in the first place? And this is going to lead us to a really cool idea I call searching the box of boxes. So, imagine this little puzzle. You've got to find a specific key. Simple enough. But it's hidden inside a box. And when you open that box, there might be more boxes inside. And inside those boxes, you guessed it, even more boxes. So, how on earth do you find that key? What's your strategy? Well, the first strategy is something we already know and love: iteration. This is exactly what our for and while loops are all about. You basically make a to-do list. You have a pile of boxes to check. You open the first box, and if you find more boxes inside, you just add them to your pile. You just keep working through the pile, one by one, until it's empty, or you find the key. But there's a second strategy, and it's a completely different way to think. It's called recursion. Now, with recursion, you don't manage a big pile. Instead, you write a function that has one very simple job. Its rule is look inside this one box. If I find the key, awesome, I'm done. If I find another box, I just call myself to do the exact same search on that new box. The function literally calls itself, over and over, breaking the problem down until it hits a dead end, like an empty box.
And this is a great way to see the two mindsets side by side. On the left, you've got iteration. It's all about managing that growing pile of work. You're constantly adding new boxes to your to-do list. But on the right, you've got recursion. It's much more, I guess, declarative. The logic is just, for the box I'm currently holding, check its contents. If I happen to find another box, I'll just run this exact same strategy on that smaller box. It's all about breaking the big problem down into tiny, identical problems. Now, understanding the difference here, this isn't just some boring academic exercise. This is what I was talking about at the beginning. This is your new programming superpower, knowing when to use which tool for the job. So, which one should you pick? Well, let's break it down. Iteration, using a loop, is usually way easier for people to understand at first. It's perfect for straightforward, linear tasks, like, adding up all the numbers in a list. Recursion, on the other hand, yeah, it can be a little mind-bending when you're starting out, and it does have a bit more overhead. But for certain kinds of problems, especially those with complex, nested data, the code you write can be so much simpler and more elegant. It absolutely shines when you're dealing with tree-like structures. And that whole box of boxes thing, that wasn't just a random analogy. Think about the file system on your computer. What is it? It's folders inside of other folders, which are inside of even more folders, right? That is a perfect, real-world example of a tree-like data structure. And that is exactly why recursion is such a natural, powerful fit for writing code that has to, say, search through all those directories to find a file. All right, let's wrap this up with the key takeaways. First, the quick, practical fixes you can use today. Stop modifying lists while looping over them, please, and start using enumerate and dot items to make your code cleaner and more efficient. Then there's the big idea. Really get the difference between iteration for those simple, flat tasks and recursion for those deep, nested, tree-like tasks. Seriously, knowing which tool to reach for is going to be a huge leap forward in your programming journey. And that just about does it. We've cleaned up our loops and hopefully unlocked a new way to think about solving problems. So I'll just leave you with one final question to chew on. What other un-Pythonic habits might be hiding in your code?